Lee, you are on mute.
Thank you, Nipur. I tell you what, I think I tried to make a horrible joke the other day about this, and that is that I don't know, I'm gonna make up that there's like some 30-second rule. If you're talking to yourself for less than 30 seconds, you're not a narcissist. But if it goes on longer than that, then maybe you've got some issues. So I was well within the 30-second mark of that issue.
Your community always helps you to not be the narcissistic person. So, yeah.
Yeah, Lee, I've changed the link in the in the Meshery development meetings since it was referring to the community meeting.
Thank you. Yeah, it definitely was, because that's what I clicked to join. So, yeah, thank you, Shivai. Wow, that clearly no one has really clicked that in the past, because it just hasn't been an issue. Good. Whew. All right. I'm looking at the participants list. Oh, thank you, Shivai. And yep, it is. I am in the earliest time zone, so I'm the one with coffee in their hand. I'm the one that gets to talk to themselves on mute this morning, I guess. So nice. Nipur shared the meeting minutes. Please, everyone, jump into the meeting minutes. If you don't have access, please request it. I think everyone here should. I see all familiar names. There are a couple of us that are new to the call today. So as soon as we kind of take attendance, we'll probably go around and do quick introductions. So we had so as everyone's taking attendance, we have one topic lined up today, and then I thought, or I know, we also have a number of other things to discuss, but I don't know that they're listed in the topics. So if you have something to discuss, please be sure to put it into the topic list today. Given that there's a few of us that are new, let me introduce this call a little bit and say that this is our weekly development call. This call ends up being well, almost like a stand-up in some respects. That's the way that we've kind of usually run it. Is we usually kind of go around, and everybody's got an item that they're either thinking of working on or that they're working on. And here's the link to the meeting minutes. Oh, there we go. Ask and you shall receive, Adina. Okay, good. So Emmanuel has been here before, or correct me if I'm getting any of this wrong, but Ayush, Lidor, or I'm sorry. Let me phrase it like this. Hey, welcome everyone. We've got a great couple of topics set up. The first of which is a presentation and discussion of Litmus Chaos, where we had a small one in the past from Raj, and we actually gave him more than a 5 minutes heads up this time to maybe come in and spend some time explaining the project to us. We're fortunate that we've got a few new faces this morning. My hope would be that we would get to a size of community that we wouldn't be able to do what we're about to do. But I don't think that we're there yet. And so what we're about to do is introduce a couple new folks. So if you're new, if this is your first time on a Layer 5 community call or a development call, will you go ahead and take a moment to introduce yourself, just to say hi so everybody can get to see you, get to know you?
Hi,
Sure.
hi everyone. I'm Ayush. Actually, I'm a third year student, third year Bachelor of Technology student at Computer Science and Engineering at Indian Institute of Technology, Dhanbad. And currently, uh, I'm actually very excited to contribute to the community. Thanks to having me here. Thanks for having me.
Oh, very good. Good to meet you, Ayush. There he is. There's Mr.
Hi,
Bach.
Lee.
Hey,
This is Sudeep Batra.
hey, I was just, I think you're at the same time zone individual. If I, is it Dallas for you? Am I
No,
remembering?
it is Toronto. I moved to Toronto actually.
Okay. All right. So you're going to be one of those real, generally nice people, one of those Canadians. I guess you're, as long as you,
Yeah, because no guns, right?
yeah, that's right. Yeah.
I know.
Yeah, you're talking.
Yeah, I mean, pretty excited to join your meeting today. I mean, I have been following your the workshop that you gave in O'Reilly, and then I was, like I can say it is because of you I got introduced to Service Mesh. And
Oh,
then, yeah, so I'm working for Ericsson as a cloud architect, and I'm working for my client AT&T. So I'm, completely devoted towards the cloud design architecture in AT&T. And the reason for getting involved in Service Mesh is we are thinking about introducing Service Mesh in AT&T, and we want to introduce it firstly for the telecommunication network functions. So they used to be like virtual network function on top of OpenStack, and then we are thinking about converting all of those into microservices. And now when we are making it into microservices, then the requirement to use service mesh, that is coming up. But obviously there is a lot of challenge to convince, because there are a lot of people like operations, security, the tenants themselves, and also the development team. So there's a lot of challenge to convince why we should implement service mesh, considering there are a lot of you know lot of overheads which is associated with introducing service mesh, like the latency and the additional resource, CPU, memory, all this. So I'm like trying to understand what I can do to convince them and also introduce it to our organization. Sorry for taking a lot of time, but I think I'll stop
yeah.
now.
I know you've been being talked about a couple of times. We're excited that you're involved, that you're in the community here. I have a bunch more things to say about what you just said, but I'm gonna bite my tongue because I'm gonna circle back to you, Sudeep. We're gonna spend some time. So very good, very cool that you're here. Karthik.
Yeah. Hi, Lee. Hi, everyone. I'm Karthik. I'm a core contributor to the Litmus Chaos project. And I'm just pairing up with Raj today to just talk about Litmus, and also very excited to join the community in general. I think there's a lot that we can do to work together in terms of how Service Mesh can be integrated with Chaos in general.
That's fantastic. I love it. Sorry. Okay. I love it when things get a little dangerous, actually. I think when we have to bring some meshy things and some chaos together, it could get pretty wild. Good to have you.
Yeah, thanks.
Yeah. And then Lidor, did I get it right? Is it Lidor or Lidor?
Just a moment. Hey, Lidor. Yeah, Lidor.
Oh, okay. All right.
So, yeah, nice to meet you, everyone. I just joined. I work together with Anton Weiss, as I mentioned also in the Slack group. I work for Natural Intelligence. I'm a DevOps engineer. We are doing it's a company that make a comparison site. Like we have the brand of Top 10. So we like comparing mortgage, insurance, all these sites, and giving the best vertical for the user. So yes, because the Corona, a lot of things happening now, and it's influenced and also my company. I'm still working there, and yeah, I want to give my my skills and to see how can I contribute to Meshery, to layer 5. And yeah, I work a lot with Kubernetes. I launch a couple of cluster and building lots of CI/CD, writing some blogs, and I hope to give from my experience to also to layer 5 and now to get into the service mesh.
This is good. All right, I'm having a good day. It's good to have all you guys. That's great, Lidor.
Thank you.
Yeah. Very good. And then there are a couple of other new faces. Oh, there he is. Mr. Yeah, Opara, I'm not sure if we can hear you. Just yeah, well, we see your lips moving, Mr. Prosper, but we can't hear you just yet. Oh, no, yeah, actually, I think you're coming through very faintly, maybe. I just stick my ear right up to the camera. Prosper, we'll come back. Just interrupt when you think you might have audio, and we'll do it. Fair enough.
Meanwhile, Folt, I'd like to chime in and say that I'm very happy to see Lidor here, and he's being modest. He is a newcomer to the mesh, but I've been working with him for the last year, and he's an avid learner, and I'm sure he'll be very fast in starting and contributing things. Actually, he already suggested a very nice simple but genius in its simplicity solution for one issue we had in the Linkerd adapter. So.
It's like I guess, Lidor, you've already passed the hazing and initiation phase. Within 24 hours, you're already contributing and improving the Linkerd adapter. So no pressure. I guess. Okay, fair enough. Very good. And then Mr. Prosper has the microphone issue he'll work on. We've got a couple of other folks. I think Calvin, you've been on before. But
yes.
Hey, there are who else didn't introduce just yet?
Maybe. We also have our chaos mesh maintainers Zhou Qiang and Chen Wen, and Gaosong. Gaosong has also been here before. Yeah, it's the second time we have been here. Yeah, maybe Chen Wen and Zhou Qiang, you can introduce yourself. Say hi to everybody.
Yes, I'm here. Can you hear me?
Yes.
Yep.
Yeah. Hi everyone. I'm Chen Wen. I'm the maintainer of the chaos mesh. I also work for some for TDB or TKB. Yes.
Very good. All right, Chang Yong.
Okay.
Good to have you.
Zhou Qiang's mic is not working, so we might skip that part. Yes.
Got it. Oh, very good. Good to have you. Good to have you. All right, fair enough. Maybe I take it back. Maybe we are to the size in this call that that maybe we won't be able to introduce everyone every time. But, so that's exciting. It's good. Lots of chaos happening on today's call. Anyone else that didn't introduce that wanted to say a quick hi? Fair enough. Fair enough. Okay, very good. Let's jump right in. Quick check on the meeting minutes. Hopefully everyone has access to those. I suspect we're missing a couple of names in the attendees list, so please don't be shy. It looks like hopefully what we can do is in the next 40 minutes, 2 topics, hopefully. The first one is to hear more about the Litmus Chaos project that we had been very briefly kind of demoed and updated about through Raj in the past. And so excited to have Karthik and Raj. And then hopefully there's time, because Kanishkar has been quite busy for the last couple of weeks now. I think Kanishkar, between the coronavirus issues and your work here on JWT. There's a lot for you to talk about how Meshery is going to support JWT. Very good. With that, I'll stop talking and let Raj take it away. Raj and Karthik.
मस्त, लेकिन बहुत अच्छा लग रहा था देखने में वो लड़का.
Okay, thanks, Lee. Probably what we'll do is I'll just set some context about Litmus Chaos generally. As a project, I'll probably introduce it for a few minutes. I'll probably take the first 10 15 minutes, and Raj can do a demo. So we could take questions either during or after this.
Perfect.
Yeah. Thanks, Karthik. You can share the screen.
Yeah, sure. Thanks, Raj. Is my screen visible?
There it is. Yep.
Yeah, perfect.
Okay. Yeah, so at the outset, I think thanks, Lee, for giving us this opportunity to speak about Litmus. So the first couple of slides are more about why resiliency is important. And I think a lot of us are already aware of the needs of chaos engineering. I think people are already adopting chaos engineering in a big way. Resiliency is something that you want to achieve to keep your services always available. And there's this slide that I picked from an event that took place last year called as GitLab Commit. So this is Dan from the CNCF explaining how your code is most probably going to be deployed. And you can see in this pyramid, I'm sure it's a little bit grainy, but pardon me for that. There's a lot of code or a lot of software that is not controlled by you, or is not something that you've actually written or contributed per se, something that you adopt as part of your technology stack. And therefore, that brings a lot of unknowns. And this is apart from the bugs that you might have in your own software. So when you deploy this, say you have your Linux VMs, you have Kubernetes on top of that, and then you have your application platform, and then your actual code. So there's a lot that can go wrong in the long run. So there is some systems that need to be put in place to ensure that your resiliency is well tested. And one of those things is to have chaos engineering. I think there is a paradigm shift that's happened in the last few years. I think since Netflix and others have really started it. So apart from the integration tests that you would do in your pipelines, you probably go ahead and do some chaos testing, which can be considered like an extended E2E, some part of it in your pipelines, your CD, or people are actually doing it on staging and production as well. So the usual engineering loop is like this. There's a lot of firefighting involved, but with chaos engineering, you're sort of vaccinating yourself. You're trying to inject faults from time to time to see how your system behaves. There are a lot of practices around chaos engineering. People do game days. People are doing continuous or background chaos in their staging. So you keep analyzing your system, you keep injecting faults, and then probably going ahead and fixing them. So this is generally an introduction to chaos engineering. I really don't want to delve too much into that. So one of the things that as a community, just to give a background, there was a project called as OpenEBS. There is a project which is actually a sandbox project in the CNCF landscape, provides persistent storage for containers. So when we started OpenEBS, we needed a way to ensure the reliability of the containerized storage platform. And then we got started with some failure testing, which slowly evolved into an actual chaos framework. And then we thought that something that's going to be useful to the community at large, not just for OpenEBS. That's when we sort of put it out as Litmus Chaos. So Maya Data is the primary sponsor, but there are contributions coming in from other organizations as well, and the community is seeing a slow but steady increase. Just this slide is just talking about what the principles of cloud native chaos engineering. I think principles of chaos engineering itself is a pretty famous page and a pretty famous concept. So we just wanted to insert the cloud native there. So a lot of us are on Kubernetes. I think the world is moving towards Kubernetes. And if you have to define cloud native today, you're actually intending to say it is Kubernetes native. So there are some properties or attributes you generally associate with a cloud native framework. So it has to be open source, and it has to have community participation, and it has to have APIs, what is popularly known today as custom resources in Kubernetes, which are also exposed as APIs. And it should be a framework into which you can integrate other chaos tools or other failure testing mechanisms instead of being something in a silo that you can use in a separate stack. It's something that should be allowed to integrate with other tools that are already there. So this is how we thought about Litmus, and the framework sort of has come up following these principles. And this slide is just representing what people are already used to. Let's say you have a pod, you have an application, and then you're having a persistent volume, and you have a lot of such native Kubernetes resources, so to say, which is describing your deployment. And then you want to go and inject chaos on this application, right? And you would want an interface, a user interface that's very similar to what you already have. You want chaos definitions to be declarative. You want it to be something that's reconciled, or you want to have a controller associated with this resource, which is actually helping you inject the faults you want to, trying to give you the visualization of what happened to an experiment. All that needs to be controlled. So we came up with a custom resource that is trying to follow the same format or the same interfaces as the other Kubernetes resources do for chaos. So this chaos engine is one such example. It is basically, we are going to speak in a moment about what chaos engine is and what are the other custom resources associated with Litmus. But this is generally trying to make a point about how Kubernetes native chaos engineering should look like. So the next one is just trying to dig into what a user's experience would be with Litmus. I'm not going to the architecture upfront. Rather, I would just want to introduce what a user's interaction or flow would be with Litmus. So you have your applications, and then you have a hub, just like the Helm hub or the artifact hub, whatever you would like to call it, the operator hub. So you have a set of off-the-shelf chaos experiments that you can actually use. You could write your own, but there are a lot of experiments which you could use straight away. So a user, typically an SRE, who is the prime user of such chaos frameworks, one would say, the other persona being the developers. So an SRE would actually go looking for a set of experiments which he or she would find most apt for his deployment environments, would actually pull those experiment CRs. And these experiment CRs are nothing but low-level definitions of an experiment, of a chaos injection. It talks about what are the tunables or parameters you would like to pass in order to actually successfully run a chaos experiment. So once these experiment CRs are pulled, you would like to tune them for some parameters which is specific to your cluster or your deployments. And then you create another resource called as chaos engine, which is actually tying together chaos experiment low-level chaos definition to an existing instance of your application. So you might use the same chaos experiment in a different way against different applications on your cluster. So you have that flexibility to tune it in the chaos engine, which basically ties together your experiment with your app instance. And then there is a host of things that happen afterwards that is mostly taken care by Litmus to actually execute it and show some results and expose some metrics. In case of a developer's experience, it's largely similar to how an SRE would do it, but you associate developers' tests with pipelines, GitLab pipelines, or you might have your GitHub Actions, for example. So you typically add a chaos stage to your pipelines, which are already doing, let's say, some integration on the unit tests. So these chaos stages implement Litmus chaos experiments. And these experiments could be something that you wrote yourself for your application business logic, and something that is very specific to your application and may not really be there on the hub, for example. Or you could take what's in the hub, develop over it to ultimately end up with your own version of the experiment. And you could actually go ahead and put that back to the chaos hub to earn some open source karma. For example, let's say you have an application which is pretty popular and a lot of people are using it. And as a developer, you wrote some resiliency tests to test that application, and you feel it's going to be useful for the community at large, for them to verify, deployments of this particular application in their clusters. So you could push that back into the chaos hub under a specific category and let people reuse it. So this is about the experience, how a user would interact with Litmus, depending on what persona he's in. Just to explain the custom resources a little bit, and also probably explain why they were built this way. So today, like I think someone mentioned at the beginning of this call that everything is a microservice, everything is disaggregated. So chaos framework should also be that way, where you probably have all the components associated with your framework sort of split into separate microservices so that you can develop on each of these without much impact on the other components, and thereby allow for more flexibility and also integration with other tools. So the chaos experiment CR is the first custom resource associated with Litmus. And like it's mentioned here, it's something that's available already, it's pre-built, and it could be in the hub or it could be in your own repositories. And it contains a granular definition of your chaos intent. So when you say chaos intent, that translates into what is the image that you're going to run your tests or your chaos actions are typically containerized. So what is the container image? And sometimes that particular image has the option to choose to inject chaos in one or many ways. So you can choose a library, and what are the permissions associated to run a given experiment. So each experiment can be associated with a strict set of permissions. So if you are a developer who is using a staging cluster that many others are using, and you want to control the blast radius and really want to stick to a minimum set of permissions, you could do that. And all that is defined. And then there are some experiment specific characteristics. Like, for example, if it's a network chaos experiment, you would talk about packet loss percentages or network delay or corruption percentages. Something that's much different from, let's say, a pod delete test for like how many times you would like to kill the pod or how many pods at a go you would want to kill, etc. So these are all there in the chaos experiment. The chaos engine is basically the user-facing CR. It's not something that the chaos experiment is something like a skeletal piece which you would put into your cluster. The engine allows you to bridge a given experiment with an instance of your application in a particular namespace. And you can choose to override certain defaults that you've already set in the experiment here. And you can also define some run characteristics, like whatever resources or pods you launched to run the chaos, whether you want to retain them, or you want to delete them, you want to expose metrics, Prometheus metrics, or you don't really want to monitor your chaos instances. All that run characteristics can be specified here. Sometimes you would like to specify some annotation checks on your apps to filter only a particular app to do chaos. Sometimes you would want it to be very broad, based on some label selections. So all that kind of filtering logic and overrides and run properties can be provided in the engine. That's really what the user generally sees. And the chaos result is another resource which is mostly used for holding results of your experiment. So we wanted to keep it separate from the other resources because this resource has a life cycle or a scope of its own. It can really grow in the time to come. A lot of times, the results of an experiment is not binary. It's not just a pass or fail. There's a lot of characteristics or a lot of application-specific information that you would like to push out as part of a result. You might want to, so there might be key performance indicators for each application that you might want to package in your result to give more information to the SREs. So the chaos result is something that we are developing over a period of time to hold that kind of information. So you can see on the right-hand side, the experiments are pre-built, the engine is user-defined, and it differs on an instance-to-instance basis. And the result is something that's runtime created and is leveraged by the exporter to generate metrics. This is a very high-level architecture. It's a very simple diagram. So there could be different applications under test. But before I go ahead with this, is there any questions we have till now? Is anything? Is there any question you would like me to answer before going ahead? Is there anything on the chat? Okay, I don't see anything. So let me just proceed. This is a very simple view of the architecture. So there are some applications under test. So we've got some chaos charts specifically for Kafka, OpenEBS, which happens to be the main motivation behind this project. And then some general Kubernetes charts and etc. And this, there could be different instances of these applications running on your cluster. And then you have a lot of chaos experiments on the hub. So you pull these together to form the chaos engine with a lot of granular control. And the Litmus chaos operator is the controller which reconciles the engine. It's probably the brain behind Litmus. So when you create the chaos engine, it launches some resources. It has an umbrella executor called chaos runner. So you could choose to actually specify one particular experiment in your engine, or you could even define a flow. For example, you might want to do a pod kill, and then after some time, you might want to basically drain a node, right? Or you might want to define your own sequence to see what happens, because chaos generally doesn't happen in isolation. It's not like just one fault occurs in your system is all right for next 15 hours. It's not like that. So misfortune can occur. Yeah.
Yeah, can I ask a question regarding these applications? So this chaos tool, Litmus, this can be targeted towards any applications, right? Is there any like is there anything different that needs to be done for targeting any application, or it works seamlessly across any applications?
That's a great question. So you can see that there is this generic chaos. So most of the experiments here are all very Kubernetes specific. So you could do all these experiments against any application. That's one use case. So you could inject this chaos and you could have your own monitoring systems in place to see what has happened. The other view or the other charts that you have here for Kafka, Cassandra, etc., is each application has a standard set of application liveness parameters. For example, in case of Cassandra, you might want to see how your ring is behaving after you've done a particular pod delete. You might want to check if the data is getting redistributed. In case of Kafka, you might want to see if your message queue is basically not broken, even after you kill your controller brokers, etc. You might want to see if your latencies between your producer and consumer is already set to a certain value, and it is honoring that or no. So these kind of liveness checks, that's the term we are using it. These are some post and pre-chaos health checks that you can do, which are all application specific. there are some standard ones that are associated with the application. So the experiments for these apps actually include those checks. So that is how they are different from a vanilla chaos experiment, which is basically going and injecting the fault and then taking care of all the other checks by yourself.
Okay, so there are different charts to target a specific use case for applications, right?
That's true, yes.
And one more question. So are you going to expand this to cover service mesh use cases also?
Yeah, that's a great question. I think we are going to do that. Probably there is an issue that we've created to do that. So there are two ways of doing it. Service mesh as a framework, you might want to go inject chaos into it. That's one use case. The other use case is leveraging service mesh to actually provide a visualization platform for what is happening with your chaos. I think in the demo that Raj is going to show, probably there's going to be a small hint of that. But yes, we are definitely looking at how to integrate with the service mesh. And also, I think Istio and other tools can basically do chaos themselves. So there is a way where we can actually integrate with that in order to perform chaos as well.
Perfect. Thank you.
Yeah, thanks. So this is a very simplistic architecture. So I was saying that when you create the chaos engine or whenever you perform some CRUD operations on your engine, the operator is going to reconcile that. Typically, it involves creating of a chaos runner, which is an umbrella executor, which will execute one or more experiments defined in the engine. And how it does that is it launches an experiment job for each experiment that's listed in the engine. And it basically, the experiment actually creates the chaos result, which again is monitored by the runner to patch it back into the engine. So the engine is more or less a single source of truth. If you're a user who wants to really look at what's happening to your experiments, you could just do a describe of the engine and then take a look. Or you could, for greater granularity, you can take a look at the chaos result. The chaos result is rudimentary today, but we are slowly enhancing the spec to put more details there. And then there is also a chaos monitor that gets launched. So this is basically exposing the metrics associated with the experiment. When the chaos experiment has started, what is its state, whether it has passed, failed, all that information is provided as metrics. So the top portion of this diagram is all user actions, trying to mark out your applications, pulling experiments from the hub, creating your engine, etc. And the litmus actions are mentioned below, where this is the automated workflow that happens. So this is probably just expanded illustration of what we discussed. It's a swim lane diagram describing the same things. Probably skip that for now. The slides will be made available. I think you can always take a look at that. So one other thing about Litmus, which I would like to mention is, so one of the things we sort of saw as we built out the framework is there are a lot of chaos tools today that are sort of coming up in the space, which is a wonderful thing because resiliency is very important, and there's always something that one tool offers compared to the other. And there are also people who might be habituated or might be comfortable using a certain chaos tool because they have always associated with a certain application. So we wanted to sort of extend the ability for them to use Litmus to not just execute a chaos experiment, but sort of orchestrate it. One of the use cases that sort of we saw that happening, we saw that thought being resonated with Intuit was basically using the experiments from Chaos Toolkit, which they've already pre-created, but they want to use Litmus to orchestrate that. That's one of the use cases. And then there are some who are using the native Litmus experiments itself. So there are a couple of integration approaches. So let's say you are using a certain chaos tool and you want, for example, let's say I'm doing a pod delete. There are a lot of ways of doing pod delete. I am doing pod delete with Litmus native library, but someone is using some other tool, for example, Powerful Seed. They could actually go ahead and create a containerized version of the same tool, or it could be even custom logic that you've been writing in your ETB pipelines. could containerize that and sort of create a job, test it out to see whether that runs successfully as a job. Then you could create a very light wrapper. I'll just share how you could do this. Over this chaos lib is nothing but a wrapper that is able to invoke this KTest resource that is going to use this particular tool to inject chaos and also manage that particular deployment. And this lib is just added on into your chaos experiment. So that's going to look something like this. So in your engine, you might probably just use a powerful seal as a lib, whereas you could use Litmus also. So that's one of the things. So there is one more way of integrating. Let's say you've not used any tools really, but you've gone ahead and written your own test case for your application. So you could containerize that. You could test it as a job, very similar to the previous type 1 case. And what you could do is you could add some instrumentation into your experiment logic to create some extra artifacts like the chaos result CR. And then you could create a chaos experiment CR, the chaos result, the chaos experiment CR, which is the one which is going to be pushed into this hub. You can create your own category and push it here. And yeah, that can be leveraged into your staging setup. You can give your SRE as an app developer who knows that there are certain scenarios you really want to try. You could create your own experiment and ask your SRE to use it. So this is about the same thing that I've mentioned earlier. So you run something in your development pipelines, you convert it into experiments, and sort of push it back. So this is roughly about it. This is just a slide to mention some details around the community. We have a monthly community sync up call, which happens every third Wednesday. And we're also on Slack, Kubernetes Slack, in the channel called as Litmus. The channel is getting increasingly chatty nowadays, which is a great sign. And there are more issues flowing into the repo where people are asking for features and sort of collaborating and even contributing. We've got some good contributions from other organizations. Really looking forward to mentoring and working with Lee and others in the service mesh community to see where chaos as a concept can fit in. One of the areas could be, the service meshes have a great way to enforce blue-green deployments, A/B testing, and have a great way to actually visualize what's happening when you're doing upgrades, etc. So Litmus or any other chaos tool for that matter can be used as some kind of a gated check, some kind of a quality gate that you could use to say that this upgrade is really going well, or you would want to go back to your older application instance, etc. That's one of the use cases I would see, but there could be others as well. There could be chaos for the service mesh platform itself to see how it is behaving. So yeah, so this is a general description that I wanted to give. I can take some questions now before Raj jumps on to his demo. It's a simple pod delete. It's like the hello world of the chaos world. So we're just trying to show what Litmus helps you with. That's what Raj is probably going to show. Yeah.
Oh, very nice. As you guys transition and Raj prepares to present, let me ask this of.
Yeah.
Can you describe the tooling or the SDK or the manner in which new chaos types are developed?
Right. Yeah. So let me just share it with you. My screen continues to be visible, right?
Yes.
Okay, thanks. Yeah, so we are actually in the process of building out what is a formal SDK. What we have now is a set of steps in the contributor guide. So the Litmus experiments themselves were written in Ansible. That's one of the choices we made early on to sort of engage the community. Most of the SRE and DevOps folks are pretty comfortable because they use Ansible in day-to-day lives. But as the project sort of grew, we've created some experiment repositories which can hold experiments written in Go or experiments written in Python, etc. So we are in the process of adding the scaffold tools, so to say, the SDK for actually bootstrapping your experiments in Python and Go, etc. For now, what we have is for the Ansible experiments. So you could actually use this a very simple script. What the script does is allows you to create all the artifacts that is necessary for providing a chaos experiment. So the experiment example experiment engine, the RBAC or the permissions that are necessary to run your experiment. You could have an attributes file which is looking like this with some metadata about what you want in your experiment and what are the permissions you want to run it with, etc. And you could use a script to actually generate all the artifacts that are necessary. It also creates a folder structure within the Litmus repo and creates all the necessary artifacts to run an experiment. So a lot of these are optional. They're not really mandatory. And for example, the chart service version is something that's a canonical representation of what appears here on the cards. The actual business logic is placed inside of the Ansible logic YAML. The prerequisites and job, again, is an optional thing. The engine YAML is a sample representation of how you would tie this particular experiment with the experiment CR with an application. So you could sort of generate this, and then you could go fill out this particular YAML with your logic, whatever pre-chaos, post-chaos checks that you have. It's written in a very simplistic manner. I could take the example of the pod delete experiment itself. It's something that's very basic. You could consider all of these as something that you can build upon. For example, you have a section which is basically trying to do some pre-chaos checks, and there are some events that we're generating as part of the experiment. This section is the one which is actually calling the chaos injection. And this is something that you could write yourself or use depending upon what tools you already have. For example, there is some templating that we have which uses different libraries. You could choose to call different libraries there. So that's followed by your post-chaos checks to see whether things are running fine. And then you go ahead and patch your result CR with what is the verdict of your experiment. So this is basically a skeletal structure. A lot of business logic can go into the utils that are being called here. We will have equivalents of this in the other platforms for Go, Python, etc., where there is an issue created about it, which you could probably see that would end up with you are basically going to just go and create experiment with a binary, and it creates all your artifacts because the libraries are already available in that particular language. And then you could go put your business logic and push it back into the hub. Yeah, does that answer?
It does, yeah, very good.
What? Yeah, Lee has one more question. Like,
I'm going to bite my tongue because it's going to lead to 6 more.
yeah. Okay, yeah, I can show the demo. Meanwhile, Karthik can answer this question in the chat.
Yeah. Yes. Yeah, that's a great question, Lee. The chaos runners execute Ansible if you're using the native Litmus lib. For example, there are Python-based experiments which you could use. Let me just share the structure, or we can go back to the presentation, which was here. So you could see this type 2 engine. So this particular one has its own envs and talks about an experiment called as k8 pod delete. This k8 pod delete is actually a Python script. It's not an Ansible experiment. So you have a chaos toolkit 1, which is basically this, and this experiment YAML is actually having a different entry point. You have a different Python script, and you have the image, which is actually having this particular experiment business logic. So you just push what you want, the tunables that can be accepted by this particular script, and it's going to be similar with other, other SDKs as well. The runner can run anything, as long as it is containerized, and as long as you are exposing the right entry points and tunables, it should be able to run other experiments as well.
Very good.
Okay. Probably stop sharing my screen. Thank you for the questions and giving me the time to speak about this.
Yeah. Thank you, Karthik. So, Lee, do we have some time, or are we eating the whole? Yeah, I can cover up within 5 minutes.
Please.
Yeah. So I have one video recording. So as Karthik said, so we are going to run one pod delete experiment, which is called a hello world, like kiosk uh, to the kiosk engineering. So this is the generic. So pod delete, this comes under the generic category. So the my target application is the STO application. So I have one setup running in my cluster, this cluster. I have 3 nodes. I will probably play one video I have recorded so I can explain properly. So this is the application. So Kylie is representing all the traffic between the product page 2 and split it up into different categories. So I'm going to inject kiosk on this pod product page. I'm going to delete this with the pod delete experiment and sees how it will react in the Kylie dashboard. So I am going to do it in a GK cluster. We have 3 nodes. Like you can see, these are the 3 nodes. Yeah, and I'm going to install. So you can see the success rate is around 100%. The traffic comes and goes to the end of the application, and it 100% success rate. So I'm going to install Litmus. I already installed, but I have to show you how to install Litmus. So it will install under this namespace, Litmus namespace. So these are the products. These are the pods. Like this slip is continuously curling this product page. This slip pod. So this is the installation of operator, the main brain of the kiosk using Litmus. So it will install some CRDs and some resource permission RBAC, and you can verify the installation. It's in the running state, and you can also verify the CRDs. As Karthik said, we are using custom resource definitions. So there are 3 main CRDs: kiosk engine, kiosk experiment, and kiosk result. So this experiment I'm going to run. So this is basically like a app store for kiosk engineering, as Karthik said. So the installation is very simple. I'm going to install the chart. You can see there is one chart pod delete I've installed. To run the experiment, we are using some admin permission. So admin permission have the cluster admin role to run the experiment. It has some permissions. Like I can show you in, like here you can see all the admin permissions to run the experiment. So this will allow. Karthik.
Sorry to interrupt, Raj. Sorry, just a pointer here. One of the reasons why we sort of started supporting this is there are 2 use cases we saw. Some of the developers want to use chaos with very less blast radius and would like to define their own service accounts. But there is another use case where an SRE typically has control over the entire cluster and wants some kind of centralized management. So just needs one RBAC, doesn't want to keep creating different service accounts in different namespaces.
Yes, Karthik, that's right. So I'll apply this kiosk, apply this RBAC. Yeah, and the second part is the kiosk engine. This will have the all the tunables you can mention. Like you can see, we are going to delete the pod, which is under the default namespace, which is a deployment resource, and the label is the app equals to product page. And these are some tunables like annotation checks. You can make it true or false. And this engine state, you can halt your experiment in between the execution. And few more tunables are there, like you can see, pod delete the experiment name, and the kiosk duration, it will run for 60 seconds, and in 60 seconds the interval is 5 seconds. Every 5 seconds it will delete the pod. So we are not forcefully deleting the pod, so this is a false. So we are just deleting the pod. So after creating this engine, so our runner will automatically triggered. So operator will reconcile and see the kiosk engine and automatically trigger the runner. So after triggering runner is creating one resource pod, kiosk pod. So you can see the events, what is happening. So after a few seconds, you can see it will goes to red state. So you can see that it is deleting the pod. Every 5 seconds it will delete.
Oh, very good. As we get toward the top of the hour, let me ask just a couple of quick questions. Is there a different user interface coming forth for the project?
User interface in the sense, yeah, this is a target application. So I create one Kylie dashboard.
So Lee, is your question about whether Litmus has its own dashboard, some kind of
Yeah.
Okay. Not yet, but we are working towards that with a two-pronged approach. One is like there are some application-specific Grafana dashboards that one would give with integrated panels for chaos to sort of correlate what's happening when application state changes along with chaos metrics. And the other one is probably trying to give some kind of resiliency information. So you could basically set that dashboard up and you could use it in your pipelines to see how you've done in terms of these experiments over a period of time. It's not really app specific chaos dashboards, but more about how you've been doing on the resiliency front overall. We're more thinking about it as standalone dashboards. There's no platform that's sort of there available yet, but it's something that we've been thinking about. We should probably have some more information about it.
No, yeah, makes a lot of sense.
Lee, for asking this question. So you can see that red. Few seconds ago it was red, and deleting the pod. For a few seconds, you can see the success rate will go down.
So the use case that's being shown here is probably the fact that the single replica, your probably deployment is not resilient. So a chaos is actually showing that for you. And when you increase the number of replicas, next time you will see that there are no 5xx errors.
You can see the success rate is 89%. So after chaos injection, as you see it will go up to 100%. So the main thing is the single replica is not resilient. So it should be like I'm injecting chaos on a single replica application. So that's why.
Nice.
You can get the events shown here. This is the events. And after the termination of all chaos pods, the application goes in a perfect state.
Very good. Makes a ton of sense. Maybe last question quickly, and we should probably wrap to make sure everyone can head off to their next call.
Yeah.
Maya data. Can you guys speak to Maya data as a supporter? A supporter of the project and kind of a part of the business model for Maya data with respect to Litmus Chaos.
Yeah, that's a good question. I think Maya Data is probably been the primary sponsor of the project thus far, Lee, because we are seeing that this was a natural extension of the OpenEBS project. But having said that, there are some contributors who are coming in, which is really pleasing. For example, Intuit has been contributing. They've both the infrastructure changes to the operator as well as new experiments. And we've got Wipro and Argo AI as some of the other contributors. So also trying to work with Intuit folks to integrate Litmus with the Argo project to define probably workflows, scenarios that you might want to do parallel experiments and things like that. So that's where that is heading.
Nice.
Yeah.
Raj, this is fantastic. We're kind of at the top of the hours. Anyone else have any last minute questions before we wrap up?
Lee, can you hear me?
Yep.
Just have a small question for you. I think is working on the network layer or the on an application layer. I think Istio as doing chaos engineering at the network layer, just routing traffic coming into. Is it doing in the application layer?
Sorry, can you explain a little bit?
Raj, I just asked about that the Litmus in doing the chaos in the application layer or it's on the network layer. I think.
Okay. Yeah, thanks, Sam. Sorry for not noticing the question on chat. Yes, you are right. The Litmus, if you saw the generic experiments where the network chaos experiments were listed, you could use that for standard network chaos. But if you are looking at network chaos on specific applications, that is also possible with the liveness checks that we mentioned, app-specific liveness checks.
Great, thanks, Karthik, and thanks for the great presentations.
Thank you. Thanks, Raj. I think I sort of ate up some of his time. I'm sorry about that.
No problem. You have covered all of them. Sorry, Lee, for eating up all the meeting.
No, this is great. This is much needed. We'll wrap abruptly with thanks to Raj and Karthik. I want to make sure that everybody that we're not holding anyone up. So fantastic. Well, Raj and Karthik, we've got more questions, no doubt. So we'll either catch you, on Friday's call or just kind of in Slack. And but this has been really informative. This is nice.
Yeah, sure, Lee.
Thank you.
Sure. Thank you, Lee, for the opportunity.
Yeah, thank you. Thanks a lot. Looking forward to really collaborating.
Yeah.
All right, very good. Thanks all. We'll resume kind of regular schedule next. We'll meet on Friday, but resume on next Wednesday as well. So. Okay, very good. All of you soon.
Bye.
Okay. Bye. Bye, guys. Bye, Raj.
Bye-bye.